Hey guys, welcome back to my channel. In today's video, we are going to see how to count set bits of a given number, right? So let's say n equals to 5, we have to count set bits, right? So 1 is called set and 0 is called unset, right? Unset. So we have to count set bits, basically number of ones in the binary representation of this number. So the binary representation is 0101. So number of set bits are 1, 2, right? So 2 will be your answer. Similarly, let's say n equals to 4, let's say, right? So the binary representation is 0100, right? Here there is only one set bit, so the answer is 1, right? So the question is simple. Basically, we have to count the set bits, right? We have to count the set bits. Um, how to approach this problem? If you have seen my previous videos, you know how to check for the last bit, right? How to check for the last bit whether that bit is set or not. How to check? I can just write something like n and 1, right? So this thing will give 1 if the last bit is set, and this will give 0 if the last bit is not set, right? We know how to check for the last bit. For the last bit, uh, so for the last bit I can find, right, whether it is 1 or 0. So let's say there are so many, like, this is a number, right? So how many bits will be there in a number? It will be 32, right? So we know how to check the last bit, how to check the last bit. But I want you to check for all these bits, right? So what you're going to do, you're going to shift, all the bits to the right hand side one by one, and then you are checking for the last bit whether it is set or not, right? So what I'm trying to say is, when n is, let's say, 5, it will be 0101, right? So at first 0101 and 1 will be this, so the answer will be 1, right? So I'm keeping a count variable and I'm checking if n and 1 is true or not. If it is true, or if it is 1, then I'm doing something like count plus plus, right? But for the next step, I have to shift these elements to the right hand side by one place. Why? Because see, this bit is already checked. Now I have to check this bit, right? So what I'm going to do, I'm shifting all the bits to the right hand side once, right? So after shifting, it will become 010. So after that, I will check for this one, right? So this is the entire intuition behind the problem. So basically, we are using shift operation, and then we are using this operation to check the last bit, right? So at first I am keeping a track of count. Count will be, let's say, 0 at first, and then I'm going to run a loop from I is equals to 0 till 32, rather I would say lesser than 32, so till 31. And then I'm going to do something like, if n is shifted to right side by I plus, and the last bit is true, if it is so, then I'm going to increment the count, right? Otherwise I won't do anything, I will be getting incremented, right? So this will give me the count of all the set bits, right? So let's say there are so many bits like this. At first, n will be shifted to the right hand side by 0 place, and for the second, and in the second loop, n will be shifted to the right hand side by 1 place, and for the third loop, n will be shifted to the right hand side by 2 place, right? So similarly, you will go from 0 till 31, right? So total 32 bits are covered. So that's how you solve this problem, right? So now talking about the time complexity, it will be of 32. Why? Because this loop will run for 32 times, right? so it will be O of 32. And what about the space complexity? It is O of 1 because we are not using any extra space, right? Other than this count, which is a constant space, so we are not using any extra space. So that's it for today. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.